Before buying an air conditioner, refrigerator, freezer, or any cooling device whatsoever, the major question to ask is what's the compressor type? These devices are always in 3 different designs: single speed or regular type, inverter type, and low voltage. In this video, we'll be comparing all 3 types and what to expect from any device that feature each compressor type, because you see, the compressor is the heart of the device and will determine how durable and effective that refrigerator, air conditioner, or freezer would be. We'll be comparing based on cooling speed, power consumption, weight and size, durability and defect, overall lifespan, and most importantly, cost. Before we continue, remember to subscribe for helpful advice and product reviews that help you avoid buying mistakes. Also, watch out for discount links on the description for fridges, ACs, and freezers we recommend from research and user feedback. So let's dive in. To determine the best compressor you want on any of your cooling appliances at home, you at least need a non-technical knowledge of what a compressor does. Every fridge, freezer, or AC has a system of piping through it, and this system of pipings have a cooling fluid running in it known as refrigerant. These pipings are split in 2 major compartments, in which one is usually hot and the other is usually icy cold. The usually hot part is the condenser located behind the refrigerator or the outdoor unit of a split air conditioner, while the icy cold part, which isn't usually visible, is located behind the inner walls of a fridge or freezer or behind the blower fan of the indoor unit of a split air conditioner. You'd also find a little constriction, which can be a capillary tube in the case of fridges or freezers, or an expansion valve in the case of air conditioners. You see, in order to create cooling in these devices, there has to be absorption of heat from one end and discharge of the heat in another end. So if we can constantly pass cold fluid around an enclosure, and when the fluid warms up, we can cool it again in another environment and repeat the cycle over and over again. We can even create ice, a process called heat exchange. Both the evaporator and the condenser are known as heat exchangers. Remember, we said the evaporator is usually icy cold while the condenser gets really hot, despite being in the same piping system. This is because of the constriction caused by the capillary tube. This constriction causes a sort of spraying effect. The spraying effect can cause the temperature of the refrigerant to drop drastically, like spraying a perfume or even hot water out of a tiny spray hole will cause the temperature to drop and make what used to be liquid to become vapor. In this case, the refrigerant becomes icy cold. This is why the capillary tube or expansion valve would be placed just before the evaporator. So where does the compressor come in all this? Well, consider the compressor as a pump in the system to make the cooling fluid, in this case the refrigerant, go around the piping continuously and build the pressure necessary to create the spraying effect within the pipes that cause the cooling. So in a non-technical nutshell, the compressor pressurizes the refrigerant flows through the condenser and gets cooled. The constriction causes a spraying effect, causing the refrigerant temperature to drop far below 0 degrees. Cold is created and heat is absorbed from the environment at the evaporator, and refrigerant is sucked in again to repeat the cycle over and over. The compressor basically sets the system in motion like a heart. So whether you enjoy that fridge, freezer, or AC would depend on the compressor type. The most common type, which is the single speed or normal compressor, has nothing special. It runs on a fixed single speed of about 3600 RPM, and when the desired temperature of cooling is achieved, it goes off, and as soon as the temperature rises again, it comes back on, and it repeats the cycle over and over again. You know a device has this kind of compressor if it continuously turns on and off at regular intervals. Also, because it's constant speed, it produces a lot of noise and vibration. The inverter type compressor, on the other hand, uses a variable speed motor. So the speed of the compressor can constantly be adjusted according to temperature of the environment being cooled. Unlike the normal compressors that simply goes off and on, running in full capacity, the inverter type uses an inverter circuit through a motor controller to adjust the compressor speed according to temperature. That means the compressor almost never runs at full capacity. It would rather run slower and maintain the temperature rather than run at full capacity and then turn off and on again. This is why inverter ACs, fridges, and freezers are more silent, energy saving, and produce less vibration. The low voltage compressors, on the other hand, are much like the inverter compressors, but can run on as low as 170 volts. They are designed specially for third world countries with power issues. So, which is better? In terms of cooling speed, we are talking about the amount of time it will take to achieve the desired cooling temperature when switched on. Normal compressors, fridges, and ACs cool faster because they run on full and fixed speed and can deliver full speed instantly. The inverter and low voltage type would constantly lower the compressor speed as the temperature drops until it stabilizes. This takes a longer time compared to the normal compressor type, but the operation is smoother, gradual, and more stable. Most inverter ACs and fridges would give you an option for fast freeze or fast cooling that simply drives the compressor to full capacity at first. But this option isn't always available and isn't designed for continuous use. So if you own a cold room business where perishable items are involved and would often need to be cooled instantly, the normal single speed compressor would be a good investment. You just need to deal with the humming sound and regular maintenance procedures. The single speed type is the winner here. When it comes to power consumption, appliances with a single speed or normal compressors deliver full power to the compressor instantly while running. That means the entire load of the compressor must be carried by the power supply. Also, the starting power to get the compressor running each time it goes off and on must be supplied. On the other hand, the inverter compressor almost never runs on full speed or consumes the full power it's meant to because it has a motor controller to adjust the compressor speed according to desired temperature and save a lot of electricity bills. Also, considering that the compressor is powered by a BLDC motor via an inverter circuit, starting current and voltage aren't really much of an issue. In inverter split unit ACs, the inverter circuit board also controls the outdoor fan speed within 400 to 950 RPM alongside the compressor. The speed is also regulated according to temperature to save energy. Unlike the single speed type that uses a single speed outdoor fan that constantly runs at 800 RPM and goes off with the compressor, adding to the starting power requirement. This makes inverter ACs, fridges and freezers up to 40% more power saving than regular designs. So if you need an AC fridge or freezer for your home, especially if you're in neighborhoods or countries with high electricity charges, avoid any device with single speed compressor. Also, if you have an off-grid power supply, probably solar or a small generator set, inverter compressors will serve you well. Good examples are the Thermocool GenPower series and the LG GenCool series. The low voltage compressors on the other hand feature a voltage regulator and are also good with power saving and can be as low as 100 watts in power rating. The only advantage they have over inverter compressors is the low voltage and stabilizer free operation, although you'd also find this feature in inverter compressor devices. But low voltage compressors are designed to run effectively even in low voltage situations. Despite these features, the inverter compressors remain the most energy saving so far. When it comes to weight and size, the inverter compressors are 20% more compact than the regular type, weighing about 9.5 kg as opposed to the single speed compressors that weigh about 17.9 kg in weight. That means a fridge, freezer or AC outdoor unit having single speed compressor would be 20% heavier than that of a low voltage or inverter compressor. When it comes to overall lifespan, the single speed or regular compressor does a lot of starting and stopping and starts at full speed. This causes a lot of wear on the compressor and other components of the refrigeration system. It's not so with inverter type, which works slow and steady. For this reason, appliances with inverter compressor don't require much maintenance compared to their single speed counterparts. If you can't afford regular maintenance for these devices, avoid single speed compressors. Simply go for inverter or low voltage. In terms of durability and defects, appliances with single speed compressors would most likely develop leakages on the evaporator and the condenser as well over time because of the sudden on and off operation, making it the least durable at this aspect. Also consider that the compressor itself would wear out over time because of the constant speed. But when it comes to electrical faults, it has the least electrical components, making the inverter type the most vulnerable. In a nutshell, if you use regular compressors, get ready to replace mechanical parts and patch leakages. But if you use inverter or low voltage type, get ready to replace PCBs, circuit boards. Anyway, electrical faults are quite rare compared to mechanical faults and wears, so the single speed guys are still the least durable with the shortest lifespan. So for the part of what we've been waiting for, which is the price. Well, when it comes to price, appliances with regular single speed compressors are cheaper and easier to manufacture as they contain less electronics with no voltage regulator, motor controller or inverter printed circuit board. On the other hand, the low voltage designs are a bit on the higher side, while the inverter types are the most pricey of the three. The price difference can range from extra 20 to 60% for similar capacity. So if you own a holiday home or a fancy camper where you wouldn't be staying for a long time, you might want to consider appliances with single speed compressors. This is because it's more affordable and can deliver cooling fast. And since they wouldn't be running all the time, you wouldn't battle with maintenance costs. Just make sure you have good power supply. But for a home or a business that runs on a lean budget, especially with limited power supply or a phobia for electricity bills, go for appliances with inverter compressor type. They may be slightly more expensive while buying them, but like OLED TVs, they would save you tons of electricity bills, and the maintenance guy wouldn't be your friend anymore. You'd basically kick him off your speed dial. Thirdly, if you stay in certain places, especially in Africa where there is unstable or low voltage situations from the grid, the low voltage compressor appliances have been designed specially for you. The unstable power situation wouldn't cause any damage to these appliances, and they would function through the toughest power conditions. They would literally regulate the voltage themselves internally without the help of stabilizers, and would do well with your generators as well. Talking about generators, inverter compressors also do well with smaller generators for those who use them. I've also added some of the toughest and the best inverter compressor powered devices from LG, Hisense, Thermoco, and few others on the description of this video. Like and subscribe for more buying advice, product reviews, and comparisons. I'm Justin. Bye bye.